Communication Society Kerala chapter, and we have our mentor of ComSoc student leadership team, Mr. Shankar Jairaj. He is the current SDLP coordinator of Kerala section. Also, we have with us Mr. Anandu Uday. He is a student representative of IEEE Communication Society Kerala chapter. I would like to thank Kerala section ECC, Mr. Sri Devshyam for hosting WebEx platform in spite of his busy work schedule. Thank you. Thank you so much. Communication Society promotes technology, innovation, and fosters creation and sharing of information among the global technical community. The IEEE Communication Society Kerala chapter proudly presents our first webinar of 2020. This webinar under the topic Discover the Sigfox Zero-G Technology. Sigfox is a world leading IoT service provider and the initiator of Zero-G network. Now, let's welcome our today's speaker, Mr. Nicolas Lesconi. He is the leading Sigfox adoption activity and spreading knowledge about the technology in business and technology circles, supporting entrepreneurs willing to build IoT projects. Thank you, sir. Thank you for joining us today. I would like to request sir to handle the session. Over to you, sir.
Okay, thanks a lot for this introduction. I'm very happy to join you today and to be able to present you more about the Sigfox Zero-G technology. To give you a few words about me, so as Krishna Priya just told you, so I am Nicolas Lesconek. I'm in charge of the adoption of the Sigfox technology, which means my role is to make sure that more people know about this technology, understand it, hopefully, and are able to use it successfully in their projects, in their professional careers, and so on, be it as an employee or as an entrepreneur, with a specific focus on education partners, so making sure your students and young professionals are able to improve their skill sets and are able to leverage their knowledge of IoT and DROG to get even better career prospects in the near future. So as an introduction, I want to say you a few words about IoT, Internet of Things, and basically what I will be speaking about, what I mean with IoT. So the first thing is, in my opinion, at least, the IoT is the new generation in the way we process and we handle information at large, be it as individuals or as businesses or corporations. In the 1980s, we had the revolution of the personal computer, moving from mainframes to personal desktop computers. Then in the 90s, we had the rise of the internet, which gradually progressed into the 2000s for a wider adoption. And end of the 2000s, we had the revolution of mobile phones, smartphones, so mobile computing, basically. And this next one, IoT, is just this next revolution. Because I believe just as with personal computers, internet, or mobiles, nowadays, or almost nobody, and most companies would not be able to function or to go about their daily operations without those technologies, which came as breakthrough, but are now indispensable for people and corporations to run their businesses. And I strongly believe this is going to be the same with IoT, that within a few years, we'll not even speak about IoT. It will be just one tool that we forget about, and that's here to improve things. Okay, so that was just my way to put IoT in perspective with communication and information processing evolutions over the last 30 years. One thing I want you to have in mind is, so in IoT, the T is very important. So I for internet should be pretty clear to you. The T is really about things. So not especially objects, smart objects, things that you handle that have a user, basically, but really things, anything, anywhere, not especially a computer. It could be a very simple sensor, very basic sensor measuring temperature, environmental condition, very door opening, whatever. Basic physical information we want to extract from the world. So don't think about IoT only about as personal gadgets, you know, the smart bracelet the connected scale or whatever personal device you can use, connected device. Really think about things, anything around you in the physical world that could give us more information. So no need for user interaction and full autonomy, meaning that that should be devices that we forget about. We don't want to recharge them every day or every couple of days as a phone. We cannot afford that. Just something that could be forgotten about and just go doing its job, sending information. And something which is important, especially for you as students and young professionals, is that this revolution, this IoT revolution, is just taking off. So everybody recognizes the potential. I just put you here a figure about the Gartner analysis company, speaking about 25 billion connected things overall by next year, which means there is a lot of opportunities for people joining right now the workforce with those technology and business expertise with these new technologies. Because truth is, right now, most companies know they will use IoT in the near future, but they don't really understand how, why, be it from a technology and a business expertise. So bringing in new expertise about how to collect data, how to collect, extract, and add value to data, away from mechanical engineering, embedded software engineering, to at the other end of the data valorization, artificial intelligence, machine learning models, building predictive maintenance models, and so on. There is a lot of opportunities coming up globally because we are speaking about a global market and a global revolution. I just put you a couple of pictures here. Most of you are probably younger than me, way younger than me, so you may not remember, but basically that's what the internet business looked 25 years ago. Jeff Bezos was still this nerd small office. Internet was still something strange that most people and most businesses didn't understand. But nowadays, it's something that's a critical part of the world infrastructure and the world infrastructure with people and companies that manage to build tremendous value, tremendous companies upon that. And I believe this is going to be the same with IoT. We'll see the rise of new companies, new leaders building things for the world of tomorrow. And you'll be the one in this picture that people will show 25 years from now. So when I speak about IoT, as you mentioned, I speak a lot about data, because in the end, IoT, industrial IoT, is all about getting reliable data. Because right now, most of the time, truth is we rely on human input, someone writing down information on a sheet of paper or in an Excel file somewhere, which leaves a lot of room for errors, be it honest errors, typing or writing the wrong value, dishonest errors, people taking the opportunity to take side and so on. With IoT, it's a great way to have a real view about what's happening, not just an impression. And the information and data can be easily structured, easily fed into data analysis models, build predictive inference, and so on and so on. So it's really about getting very reliable data, true data, getting it almost real time, which is a huge switch of way to operate for most companies. So real and new data. So if you think as this the petroleum industry, this revolution, this technology, new technology revolution, is a way to tap into this unexplored data mine, which is in the physical world. A lot of data, which is, but so far we were not able to extract because the cost of extraction of this data was way too high, way higher than the value we get from it. Now we are putting together the technology to make it possible and the business part of it, which makes it relevant from an economic point of view. Extracting this physical data at a reasonable cost and bringing in real value. Okay, so that was about my introduction. I hope I didn't lost you yet. So now I'm getting into more specifics about Sigfox itself. What is this Sigfox OG technology about? So Sigfox is the world largest zero-G network. So zero-G, as you may guess, is the way to step aside from the 3G, 4G, 5G evolution, which is mostly about getting more data rates and more battery consumption, more and more and more, which is very useful in some use cases when you need a lot of information. If you want to watch a video on your smartphone, if you want to extract live telemetry information from a car, whatever. The other way around is focusing on simplicity, cost efficient, very low energy communication, and simplicity of operations. A very simple way to get basic physical information. That's it. So a way to extract information, as I said, and also a way to build a safety net, having a backup communication channel when your primary connectivity fails. Let's say most of the time you need high bandwidth communication. You need, I know you need 4G, you need Wi-Fi. That's more relevant for your use case. What happens when there is a power outage or where you lose your primary connection? You cannot afford to lose your data. So the zero-G can be used and is used by some of our customers as a safety net, as a backup connectivity service. Sigfox right now is available in 70 countries and should be very soon in India. We have a partner setting up operations in India right now with first tests that have been run in some businesses in the Kerala region. So if you're interested to know more about how to get in touch with your partner in India in the near future, please drop me a message and I'll be able to make introductions or tell you more about their plans for 2020 and 2021. So Sigfox is one communication service available in 70 countries, which is roughly 1 billion people right now, covered live, and about 15 million devices sending 26 millions of messages each day. That was last year's figure. I assume it's pretty higher right now. Just to give you an idea about what we're speaking. I'm speaking about opportunities, about what will be tomorrow, but years of today. That's a technology which is available right now in 70 countries. Okay. So zooming in, does it mean this zero-G? What happens when I have information I need to send? So let's say you want to send information, examples on the map about my animals. I'm tracking the whereabouts or the safety, the well-being of animals. I'm tracking water leaks. I'm tracking information about industrial operations. So I have a sensor that detects this physical information, movement, temperature, leakage, whatever meaningful in your use case, broadcast it using our radio protocol, the zero-G radio protocol. It gets picked up by our antennas. So we set up physical infrastructure, base stations, antennas listening to radio signals. They detect those communication. They get processed, authentication, security mechanisms to make sure it's real information. We store it, and right away it's pushed towards your own application servers. So depending on your own who you work with, where it is hosted, the programming language you are using, whatever, we just make sure we send the information the way your application know to process it. I'll get into the details later on, but that's the big picture. Find something valuable, meaningful to say, broadcast it using the radio protocol, and receive it on your application server seconds afterwards. That's it. That's very simple. No complex mechanism involved in the communication part. It's really about finding something valuable to say, basically, and finding a way it's valuable in the end. Send notification, have a live dashboard, whatever is meaningful to your business or your use case. Okay. Before getting into the technical details, I'll illustrate that with a real use case that maybe will help you get a better understanding about it. So I will tell you a little about supply chain, which is one major use case for the IoT. That's critical business, and we all know it right now with the global COVID-19 crisis. Supply chain is even more important than ever, and knowing where things are, in which conditions, Where are they stored? When will they arrive? Did they get stolen along the way? All that kind of information, which is very important. So I'll use an industrial examples, what they call reusable packaging, basically boxes that I use to transport goods. It's mechanical parts for the automotive or the aerospace industry, be it parcels, be it chemicals, anything that needs to be transported, basically. Okay. So focusing on examples that we have with 3 customers. So 3 European. PSA is an automotive group, one of the leading automotive group in Europe, that needed to track their auto parts between the industrial sites, optimizing the logistical loops, improving usage, reducing cost. But it's all about reducing cost, as you may guess. Airbus, a major aerospace company, same thing, tracking parts that are moving across sites that get lost sometimes. Sometimes they need to they produce more than they would need just to make up for the inefficiency of the supply chain. And lastly, Michelin, which tire manufacturer, again, global company, industrial sites all over the world. Inventory is not very clear all the time. Sites know where they will get the next shipment, so they overstock and so on and so on. Again, it's very often all about reducing and mitigating risk and reducing operation costs. That's the first thing that you would get deploying an IoT solution. So basically, Michelin, in that case, they were tracking containers, shipping that goes on boats across Europe, Americas, Africa, Asia, transporting their goods. Very basic, but an information that didn't get before. So zooming on this use case with Michelin. So basically, supply chain manager usually have intrusible vision. They roughly know what's happening, or at least they think they know what's happening. But the truth is, some information get lost because you have a lot of companies, a lot of suppliers in the chain. Information is not properly shared across suppliers. Some don't want to share because it allows them to hide some shady things that may happen in between or whatever. IoT is just making sure you see what happens. As I said earlier on, reliable data. That's it. It's just making sure you clearly see what's happening, and then you can take the decisions based on real information instead of taking decision based on I think that, or we used to do that way, which is not good enough. A quick prototype. As you can see, this is a demonstration device, not a professional IoT device, something that students can build in a lab, basically. Basic sensors, sensing movements, temperature, that kind of basic information. It's very cheap to build. And sending information. And the network itself interpolating the location of the container. So they did not have to build a new container or to suppliers to install something specific, to install a gateway or whatsoever. Just something they put with the shipment and sending information. So this intermediation, no more need to rely on the information shared by the shipping company, by the boat company, and so on and so on. That way, they were able to get the information live, directly, about where the container was. And that way, a lot. They learned about stop in Spain for 2 days, which was not told to them. They knew about the way their goods were stored. Good news is tires are not very sensitive goods. For example, if you were shipping vegetables or fruits, if you know that they have been stored under the sunlight for 2 your shipment is probably lost. And you don't have to wait for reception to know that, and you can act quickly. So basically, it's all about it. Visibility of information, traceability. Traceability meaning that if something bad happens, your containers get lost, broken into, it get destroyed or damaged. Thanks to those little sensors, you will know when it happened and where it happened. So basically, you know who was in charge, and nobody will be able to hide his responsibility, which is pretty something that insurance companies, for example, are pretty eager to know. cost, where you are losing time, where you are losing money, an ability to learn more and learn with real information, monitor and anticipate, make better business decisions in the end. So that was the big overview. Let's get into the technology itself. Okay, I will try to get from the sensors themselves through the telecommunication part, what is this 0G radio protocol, to the cloud processing part. Okay, and I will try to stay generic to make sure that you don't need to be a computer science engineer or an embedded engineer or telecom engineer to understand that. Because myself, I am not, so I will make sure that it's understandable to everybody, okay? And anyway, if you have any questions, free to add them and we'll address them in the end to make sure you got the information you are looking for, okay? So first thing, no technology can do everything. To tell you that, most probably are trying to sell you something or are lying. So you cannot do everything with the 0G technology. If you need huge number of messages, constant telemetry, your point of sales or ATM or what's, you will need another solution because the 0G is all about sending small information every now and then. That's for what it's made for. Same, if you need to send amount of data, video stream, high resolution picture, that kind of thing, it will not go through the 0G technology. Again, it's all about sending very basic information, small messages. That's what makes up for the high efficiency and the very low energy consumption. You will be able to use the 0G to alert when your security camera is down, for example, but you will not be able to send the whole video stream. Okay? But what is, and the 0G is perfect for, is simple solution. Application, especially if you need devices that move around, that don't stay in a place that you control, that need to be able to work in your company's facility, at your customer site, during shipping, and you don't know in advance where it's going to be. An operated communication service. You need someone out there putting a telecommunication infrastructure, somehow a telecom operator. If you need high autonomy, we're speaking years, we are speaking 2, 3, 5 years or even more for some metering solutions. If you want to track things, basic monitoring of sensor information, security, as I mentioned, as a backup, and it could be very simple. If the camera is not working anymore, someone open the door to this remote site, which should not be open. We know that's an issue. We can act right now. It's a very simple information. Agriculture use case, which are big as well. Knowing condition of the soil to improve when you plant your crops, when you harvest them, when you water them, diminishing waste and making sure you optimize your yield with crops. Same with cattle. Whatever the animals you are raising, improving their health and safety, and making sure you get the more out of your agriculture exploitation. Those are some examples that are perfectly suited for the 0G technology. If you are interested into highly detailed information about the protocol itself, bear in mind it's open, it's published online. So you can just head out to this address on build.sigfox.com and get the full device interface specification. If you want to get into the details about how a frame is constructed, because it's using the 0 protocol, which is not IP, it's not TCP/IP, it's not UDP. It's a different way to construct the messages to make it highly efficient. So I will not get today into the details, the deep detail of the radio protocol, but you can read the specification there, okay? So it's all about small and optimized messages. And when I say small, I mean a few bytes. You may be used to work with kilobytes, megabytes, gigabytes. It's down to the basics, basically back to the basics, which is a few bytes, very small information. It's information which is made to be understood by machines. It's not human readable information. It's not JSON files, it's not XML files or even text files. It's really a few bytes describing your information. And giving you a few examples. I want to know the location of my good. It's in 6 bytes. Of course, I will not write full text itself, but describing it in binary is pretty easy to do in a same. You want a very accurate temperature reading, 2 bytes is way enough. Lab grade precision measuring, okay? And even sending nothing is a message. It's a proof of life. In some use cases, your device will just send an empty message every day, for example, every week, which just means I am still working. And sometimes it's good enough. It's very cheap, very easy to do, and it avoids you having someone traveling to check if everything is okay. I'll tell you afterwards what I was speaking is called uplink, basically messages coming up from the device to the internet, from the thing to the internet. And what we call downlink is how do you get information back to your device, which is usually a way to change configuration, switching to scenario B, for example, or scenario 1, 2, 3, 4. As you can see, you could have of pre-configured scenarios, and very often it's a way to change the sampling frequency or the sensor scale. Basically, we detected that something is going wrong, something is weird. Instead of sending the information every day, please send it every hour now. Just the information that you get back to your device. So this one is a duplicate. Sorry about that. The previous one was nicer, but it's the same way. Okay, up to the cloud, down from the cloud. Uplink, downlink. 12 bytes maximum up to the cloud, and 8 bytes down to the device. And then you have some information about the duty cycle. Maybe something that we could go in the question if you have about them. It's basically explaining the limitations due to local regulation. And those are the rules especially applied in the Europe and Middle East settings. The 0G protocol is using what we call the ultra narrowband modulation. But it's a way to concentrate the energy used for transmission on a very tiny part of the radio spectrum, improving the range of communication and improving the resistance to interferers, perturbation in the radio spectrum. Because we are not speaking about making things work in the lab where everything is clean and perfect. We are speaking about things that need to work in the real world, where other peoples are using radio waves to send messages. Some are playing by the rules, some are not. Sometimes the rules are not very clear, and so on and so on. So that's why it has been designed with a very robust radio modulation and a way to make sure both the information will get through and that we can have a lot of concurrent messages. You can see on this picture, basically that's a snapshot of the radio spectrum. With a black background, you have on the x-axis the frequency in megahertz. On the y-axis is the received power intensity. So you can see those tiny waves. And in the bottom, a green and yellow, it's a waterfall in time. So the further down you go, the further back you go in time. And the brighter the color, the higher the power. And you can see rounded in those little red circles, that's 3 0G frames that have been received by this receiver. And you can see they look like tiny needles in this radio haystack. Basically, you could have hundreds of them at the same exact instant, at the same exact place, being processed concurrently without issue and without the need for your device to ask for permission. The emitter just say what it needs to say, and that the network task to handle the rest and to make sure the information is properly processed. And I had a nice zoom. So that's what we call random access. You don't ask for authorization. Usually, the way communication systems are built are in a way where the network itself discipline and give orders to the emitters, to the terminals, okay? Saying who can speak, when, and at which frequency. Basically acting like a teacher in a classroom, saying, okay, now, Nicholas, you can speak right now. And now you know you can speak. And this way you only have one person speaking at a time, which is easy to hear it. But you only have one message at a time. In this DRG architecture, it's the other way around. The devices, the terminals, are the masters of the communication. They don't ask for permission, they are not synchronized, there is no preamble negotiation before speaking. It's really, you have something to say, you just say it, and maybe a lot of devices are speaking at the same time, but that's the job of the network, to detect all those messages and process them. The network is not giving orders. It's receiving messages and making sure it processes it. That's what contributes to high capacity of that network, because IoT is having large volumes of devices. So you need to handle a lot of concurrent communications. The base stations are listening, and such as telescopes, for example, receiving all incoming communication and making sure they detect the DRG, the Sigfox message among what's coming through. And you have a detail, basically, each message is sent in 3 frames at 3 more different moments in times and on 3 different frequencies with a pseudo frequency hopping, making sure the probability of collision with other communications is as low as possible, thanks to this time and frequency diversity. And what makes finally this network capacity? So I spoke about ultra narrowband, the fact that you can have a lot of different frequencies used at the same time, frequency and time diversity. Each message is sent on different moments and on 3 different frequencies. And finally, we have what we call spatial diversity, because contrary to your mobile phone, for example, a Sigfox device is not speaking to one. It's not speaking to one gateway. It's broadcasting the message around. It will be picked up by 3, 4, 2, whatever number of receiving stations around. The more, the higher the quality of service. Sigfox deployments are designed to make sure that 3 stations are covering each communicating device. So the combination of those factors, ultra narrowband and spatial diversity, makes for massive capacity. We are speaking millions of messages a day, and high quality of service, making sure that using no synchronization, no pairing between emitters and receivers, and operating on shared radio bands, we are able to guarantee users and customers the quality of service. I'm zooming in. So basically, a small study that was published by a university in Europe comparing and you could Google it. You have comparison across different communication technologies. That's really the key thing with Sigfox and DRG is the ability to operate at scale. Because using other technologies, everything will work fine. Maybe when you have 1, 5, 10, 100 devices in the locality. But when you have thousands of them, capacity crumbles, and you will lose a lot of data. So that's really the key thing, is that this DRG protocol has been designed to be future-proof and to be able to handle massive IoT, and not only simple experiments, which you could do a lot of different ways. Maybe I'm speaking too much. Don't say that's because I'm French. I will try to go faster because I have still a lot of things to say to you. What a way to zoom into what we call bidirectional communication. You know, the downlink I mentioned earlier on. The important thing here, I don't know if I have another way to describe it later on, but it's about what makes the long battery life. We live for a very long time because they sleep most of the time. You can see that here. You send a message, then you go back to sleep, and you open your reception window to receive the reply from the network. And the the reply comes from your own application server. Basically, what it means is that most of the time, the device is just sleeping. That's what maximizes the battery life. Key factor, because when your device speaks, it spends a little energy. We are speaking tens of milliamps the seconds needed for communication, which is low energy. But the key thing is that most your device is sleeping. It's not even listening, because as in real listening use less energy than speaking. You get tired more quickly speaking than listening. But listening still takes a lot more energy than sleeping. So what we do is that whenever your device has nothing to say, it just sleeps. And then it will spend, I have a typo in my slide, it's not 6 nanoamps, I wish, it's rather in amps range, with new chipset advertising, let's say, rather 600, 800 nanoamps idle consumption. Basically, what it means is negligible. What will decide your battery life is what you do yourself, application-wise. It's not the communication. Communication should not have an impact on your battery life, on the way you design your solution. It shouldn't have an impact on the life cycle of your solution. It's all about how costly is the information you are measuring. That's it. That's what will decide your battery life. And it's highly predictable given the way the zero-G protocol works, meaning that you can finally predict your battery life and optimize the way you will recharge and replace the batteries. So keep in mind, most of the time, the devices are just sleeping, doing nothing, waiting for an event to happen, or waiting for the next moment they are supposed to measure the information. And that's purely application controlled. The Sigfox part of it is just about making sure when you have something to say, the message goes all the way to your application server. That's it. But most of the time, Sigfox, the communication part, will use close to zero energy in your overall solution. Okay, so that was the zoom on the protocol itself, on the way communication works from the to the Sigfox cloud. We are halfway there because we still need to speak about the cloud part. How do I process the information on the cloud side? But I want to say you a few words about security. Because as you may know, security in the IoT world is very important. Sometimes it's been overlooked, and which can lead to disasters. Badly secured solutions can lead to disaster, it's going bust because of that, and so on. Something important, I'm not sure I told it clearly enough before, but messages that are sent by your Sigfox are sent using the Sigfox zero-G protocol over the radio waves, and then it's processed by the Sigfox cloud. This part, not the public internet. The devices are not using TCP/IP stacks, for example. They're not using Wi-Fi or that kind of links where it just or where you just behave like a standard computer, which means that those devices cannot be compared the same way that TCP/IP based IoT devices, such as we had in the past with recording systems, security cameras being infected by worms and then being used as attack relays towards other companies. That could not happen with this architecture. Okay, you still have security things to care about, but this one, this vulnerability does not apply to Sigfox device. Important. And adding to that, that most of the time your devices are as sleeping. Sorry about that. This means that they cannot be attacked the same way as standard TCP/IP devices, because you don't stay there with ports open for anyone to come into. Your device is just sleeping and there is no communication link, no way to get into the device remotely. Okay. And then the important thing I want to say to you about security in the IoT spectrum is to make sure you understand that so security is about making the right assessment, for sure. We'll get on that. And it's all about making sure you understand your whole chain, because your whole security chain is only as strong as the weakest link. And IoT, you have a lot of moving parts from to your application servers. And what you should not do is this. So you can guess what happened here. So this is a remote site. You don't want people to break into. So what you do is, okay, what I need to do is I need to have the most secure lock possible to make sure nobody can break the lock. And this way, my security will be perfect. And what happened here? So the lock is probably very expensive. Everything is being done to make sure that the lock could not be broken. Most probably the people were very happy because they achieved what they were looking for, having a very secure lock. But they overlook the whole security picture. And what happened when you have a very secure lock and a very weak door is that people find a way to break into. So keep that in mind. It applies to IoT, but to a lot of things. Security is making sure that all bases are covered and not only focusing on the obvious. Because if people want to attack you or to break into your system, they will find smart ways to do so. And they will not only focus on the obvious. So in the IoT, it means you have to consider everything from the device security, basically what happens if someone takes control of my physical device. I don't know, I put a tracker container. What happens if someone take the tracker? What can they do with it? What kind of information can they access on this device? Do I have debugging ports easily accessible? What is available in the memory space, and so on and so on. You can add extra layers of security here, if relevant. You can add credential storage solution, hardware-based, for example, using secure elements, that kind of thing. Important thing is always to do a proper assessment and then sure you balance the security level you need for your application, because everyone wants max security, but everything comes at a cost. So it's all about assessing risk. What do I need? How sensitive is this vulnerability? How sensitive is this information? And what can I afford? What can I afford? On my device, for example, in that example, using a secure element will add extra cost of components. It will add extra energy consumption, so shorter battery life, which means higher maintenance cost. Is it relevant to my use case? That's always the question. So you have to consider what happens on the device. What happens when the data is in motion? Basically, once I found the information, extracted the information, I'm broadcasting it using the Sigfox protocol. What could happen if someone was intercepting this information? Is it dangerous to my operations? Do I need to add encryption of the message itself? Or is this sequence of bits, this 101100, something that nobody could do anything with? That's something to be decided again, risk assessment. Do I need to add encryption? What will happen if someone intercepts the information and use a man-in-the-middle attack, trying to then resend the same information over the radio network? So in that case, you have built-in security mechanism that make sure that there is integrity check, authentication check on each message received by the Sigfox cloud. Basically, man-in-the-middle attacks, replays, identity spoofing will be detected and will raise an alarm, and the message will be ignored to make sure that no fraudulent, no fake message will make its way to your application. So device, data in motion, then you have entering let's say, the Sigfox part of the security responsibility. The way we secure our sites, the communication link between our base station and our core network. So everything goes through VPNs, rotating credentials, credentials that are not shared. Each base station has its own VPN link with its own credentials that can be revoked anytime if there is a detection of an issue and so on. Then you have security on the data at rest. It made its way to the Sigfox cloud. So everything is hosted in data centers that we manage directly. It's hosted in Europe, meaning that, for example, US laws do not apply, which can be an issue for some companies. So it's hosted on all data centers that we manage. It's replicated, of course, in case something happened to one site, and so on and so on. Finally, and maybe the more important part of the security chain, because maybe that's the more overlooked, it's security level on your application servers itself, or the application servers of your customers. Because sometimes you can have top-notch security mechanism on the physical device, top security on the data in motion part, top security on the Sigfox Cloud data at rest side. But in the end, if you store all this data on a database which is accessible online with admin as a password, for example, which happened, then you are at risk, because that's the way you will get an attack, or someone will steal your data. So it's very important to have all those parts in mind when designing security. And security has to be considered from day one. Adding security along the way of a project is very difficult and is very usually a good way to make mistakes. So this security has to be considered with proper risk assessment for each part from the beginning of an industrial project. Of course, if we are speaking about a hobby project or a school project you are doing, it's not a big deal if someone steals information about watering of the plants or basic information if you just test. This is if you are to build tomorrow's professional solutions that need industrial security. So yeah, detailing what I told you about the mechanism on the Sigfox side, secure hosting, robustness of the radio protocol, authentication of each message, and so on and so on. Okay, and crypto capabilities that can be added on the relevancy for one use case. Okay. Time is running fast. Giving you now a bit more information. So you should understand, hopefully, if my presentation is good enough, you should understand now what this zero-G technology is about. Simple messages, extracting information from the physical world at minimum cost and maximum simplicity, and sending it with very low consumption to the cloud. But what does it mean to build a product that will operate on this network? In fact, there are a lot of them. I told you earlier on that there was 15 million devices right now on the network, and they come in all form and shape. Here on this picture, you have a Timo device on the top right. You have a parking sensor on the top left. In the middle, you have two opposites. First line, where it's written Sensorive. It's a device designed to monitor concrete production, dryness of the concrete during production, to optimize quality and to optimize efficiency. Very industrial. And in the below this one, more fancy looking device, it's a consumer device, a tracking device that you can put in your handbag, in your suitcase, to make sure you can track its whereabouts, or maybe you can restore it if stolen. And on the bottom right, it's a swimming pool sensor. Again, very different application. All of them are using the same technology in the end to send this information. The key thing is finding where can I get information be valuable, and then the device will take all kind of form and shape depending on how it needs to operate. Industrial setting, for example, the parking sensor, you need to make sure a car can go over it without breaking it. Is it a consumer good? It needs to be fancy, nice looking, small enough, and so on. Does it need to operate outdoors, water, and so on and so on. So a lot of things to take into account on the mechanical part of it. And we open one, so that this is a demo device. If we open it, what do we have? We have this casing, which is all about which condition should it survive, basically. Indoor, outdoor, will it be treated gently? Will it be in a factory where anything can bump into it? So that will decide your materials. You have a battery, you have the sensors themselves, getting the information, And then at the heart of the electronics, you have the microcontroller. So we are not speaking computers at the beginning. We are really thinking very basic microcontroller, very little memory, very cheap solutions that are processing. That's where your code will live, processing the information and sending them to the Sigfox modem, which is where it's translated in radio communications. And final part is the antenna itself, which is a critical part because that's what makes the difference between a great solution and a very bad one. Because that's performance will be decided basically. Modem or module, they are not made by Sigfox. You have a few logos here and there, but basically the Sigfox library is available for free for any company willing to build its own modem or its own module. And you can yourself shop them from big companies like NXP, ST Micro, On Semiconductors, or buy ready-made modules. A lot of them are made in Asia. I have Lighton, Weisel, Inocom, Georgine, and so on. Right now, a module costs as little as $2. For $2 right now, in small volumes, you can get a ready-to-use Sigfox module that you can on your project. A few words about antennas. The key thing to keep in mind, if you want to design an IoT solution and you understand radio frequency, RF, basically, you don't understand how an antenna works, don't touch it. Basically, that's my only recommendation. If you don't understand how an antenna works, make sure you find people that can help you. And you have documentation available online. Hire someone, an expert, or buy something which is you just to plug. But that's really the best way to mess a project, is trying to mess with the antenna when you don't understand how it works. Myself, I don't understand anything with antennas. It's still black to me. So if I were to build a project, I will make sure to find someone who understands and that can help me get maximum performance for my solution. So you have a lot of providers available and a lot of sizes and shapes possible. Again, depending on what are going to be the operating conditions of your device. Can you afford a bulky antennas that will work great? Do you need a very small one because you need a small form factor for your final product? Like in a smartphone, for example, what the antenna nowadays is pretty and very small within it. And we don't have these sticky fingers that we used to have in older phones. It works a little less in terms of performance, but that's a compromise, except performance versus design and size. Again, a lot of suppliers available. Not getting into the detail there. Batteries, one battery is not the same as another one, and it's all about finding the thing that fits better the life cycle of your projects. How much energy will you need? How much lifetime do you need on your battery side? And then you can find the one with form factor. Do you want a coin? Do you need a coin cell? Will you use lithium batteries, chargeables? Will you use basic batteries, and so on and so on? Okay, now time to speak about the cloud, which will be my last section before getting into the Q&A. So now we understand how to build a program that will sense information from the physical world using whatever sensor, digital, analog, getting movement. You can use an accelerometer, you can use a temperature sensor, CO2 sensor, whatever need. Any physical factor you can find a sensor to measure it, okay? But once we do that, we send them over the DRG network because it's useless if I cannot use my, right? So when you purchase a Sigfox subscription, you have access to the data management system. It's part of it. It's part of the service. And you will get retrieve your data. The first one is using the Sigfox web platform. Okay, basic interface where you will be able to see your messages. It looks like that. Okay, my device its ID, its unique identifier on the network. So remember, we are not using TCP/IP, so there is no IP address. This is the ID of the device, of this particular device, and it's unique in time and unique on the network. So every device signed with 2C0694 and is on private key will be forwarded to me because I'm its owner. And so this example is already 3 years old, but whatever. And you can see that 2C0694 sent 0123 cafe. That's hexadecimal description of the binary message. So let's assume this is very important information for my application. Okay, and then you have meta information about which station received it, how good was the coverage at that point, and so on. So that's the first thing. When you do your first tries, you will use the Sigfox Cloud interface. Then you have REST API, standard API to pull information from Sigfox. But the channel is what we call callbacks. Callbacks, some other it's called webhooks. Basically, it's pushing information your way. Because using APIs only, it would mean that you would be calling Sigfox every second or every minute saying, okay, do you have new information for me? Do you have new information for me? Which is not efficient at all. So what we do is that every time one of your device in all your pool, no matter if you have one because you are just a student starting or you have a million because you are a big corporation, it's exactly the same. You are a customer. So you will configure your callback saying, when one of my device says something, send this information to this server. And that's it. And live, you will get this information delivered to your server instead of you coming and asking for it. They are fully customizable. So that's very important because it means that if you already have an application, you can easily ingest data coming from Sigfox. You don't have to adapt to the Sigfox format. Just say what is your preferred format. That's also the channel used to send information back to the device. And of course, you can build your own cloud application, but you have very easy integration available with major from Microsoft, Amazon, IBM, Oracle, ThinkWorks, SAP, smaller companies like the Things.io, IOFrog, a lot of platform providers, and most of them are fully compatible with the Sigfox Cloud. For example, if you want to work with Microsoft Azure, we have a particular partnership with them, meaning that you can very easily connect your Azure IoT infrastructure to the Sigfox Cloud, making it seamless. And on the Azure part, and it will work the same with AWS, you can see, same way to interface it. That means that your own application already exists on Amazon or Microsoft, can receive data coming from Sigfox, but also from other sources, other inputs, and you can just together and sorry about that. Sorry, my English is failing me. You use data coming from various sources and put them together and your system, not only on one provider, because there is complementarity between communication solutions. You could have part of your infrastructure using Sigfox, part of infrastructure using human input, part of your infrastructure using, I don't know, 4G or 5G NB-IoT whatsoever, and or LoRaWAN, whatever relevant on one use case, and you can put them all together. There is no proprietary part of it. It's all about making sure the data you extract can be used properly on your system. A few examples here about some platform providers. So you have very generic one. I spoke about Microsoft, IBM, ThinkWorks, Amazon, a smaller one like Ubidots, and so on. And you have companies providing solutions tailored to one use case. The utility business, the smart city business, the smart building, and so on and so on. You can still build yours, but you can also purchase something which is already existing. So that's what the last to say you about the cloud part of it. That's it regarding my presentation. Final words I want to say to you first is thank you, and we'll jump into your questions right afterwards. You can join the conversation on our Slack community if you want to build your own Sigfox project tomorrow, or you just want to learn more, or you want to discuss with other people around the world working on zero-G solutions. You can join there and get part of the conversation. And something else I wanted to say is that we have dedicated programs to help and to support entrepreneurs and students working on their projects. So I invite you to either ask on the Slack channel or go build.sigfox.com, build.sigfox.com, and you will find all the information about the programs available for free to students and entrepreneurs. For example, the best entrepreneurs building Sigfox solution, we make sure they get access to easy and free credits on Amazon or Microsoft or co-marketing solutions, that kind of thing. And if you want to start working with Sigfox right now in India, you can. So the network is not live yet. It's going to be in the near future, but you can already start working using what we call emulators. So just to get in touch with me, and I will you the information about how to purchase a small emulator that you can plug on your computer, and then the computer will act as a Sigfox base station, and you can start working with Arduino boards, ST development kits, or whatever hardware solutions you have if you want to start building IoT solutions. So thank you again. I don't know if we have questions that I can address right now. Try to open this menu.
Thank you, sir. Thank you, Nicholas. This is Shankar. So a general announcement. So if you have any questions, you can just shoot your questions in your QA tab or personally to the panelist. We'll sort accordingly. Thank you, Mr. Nicholas, for this wonderful session in from scratch, from IoT to the Sigfox systems. So thank you so much for giving your time, valuable time, for giving a brief introduction to all. To add on that, to all the attendees, we have a Sigfox Education Partnership Program where you can register there as the speaker has mentioned, and start away your innovation projects from there. So it's actually, I will repeat, so Sigfox Education Partnership Program. Right, sir, Nicholas?
Yes, exactly.
Okay, so if you have any projects to build upon, he has already covered that in the last event. Like if you have any projects or to work on the platform, definitely will help you out. So I hope you take this opportunity to the next level. So if you have any questions, please let us know. We will wait here.
Yes, I can see that some of them have been sent to me privately, so maybe I can address them right now, if you're okay.
Yeah, sure. Please go ahead. Thank you.
I'll take them from, let's say, first in, first out. So I have a question from Vinod asking, is Sigfox able to track containers on the ICs today? So that's a great question, so the short answer is not yet. Let me explain. So what happens right now is that Sigfox and these operators in each country set up physical infrastructure to receive the information. As you may get, they put them on the ground, and we don't have coverage in the ICs yet. So what you can do in terms of coverage of containers right now is getting the information as long as they are few tens of kilometers from the coastline, because the radio signal propagates well over the sea. So very often up to 100 or even a bit more kilometers, we still have reception. For example, in Europe, when Michelin did their first test, all information in Europe was properly covered, between France and England, that area, Spain, Portugal. But information was then lost in the Atlantic Ocean before arriving in Brazil or in the US. So what we are going to do is we should have in very near future the first launch of a satellite. The whole idea is to have a satellite coverage in a couple of years that will offer additional coverage for very specific use case that will be IC tracking, because right now your only option is regular satellite service, which is very expensive and very power hungry. You can do it for a boat, but you cannot do it for each container on the boat. And the other use case may be agriculture in remote areas in Brazil, Australia, that kind of very large countries. Short answer, no tracking on the ICs yet. Long answer is it's coming soon using satellite with first trials that should be available end of the year. Next question I had was from Reshma, asking if we can use the technology in medical devices to message the patient's record. This is a tricky one. So you have quite a lot of cases right now around the medical situation, especially with this current sanitary crisis. For example, we have companies offering solutions for caring for the elderly people. Either having something that will detect a fall, so making sure that when a grandmother or grandfather fall, the information is detected and a message sent to his family or to the doctor to avoid the person laying on the ground for hours or days if they are living alone. We also have solutions, again, for elderly people, non-intrusive monitoring solution to make sure that it's, especially for places where you have elderly people living at home alone and in need of care, but that you don't want them to go to a nursing home, basically. And so what it does is monitoring to make sure that the light has been turned on today, or water has been used, that kind of information that prove that everything is going well. And when nothing happens for a day, if the light hasn't been turned on there have been no use of water, you know that there's an issue and you need to alert the family or the medical services. Getting back to the question itself, technology-wise, yes, you can send medical information. This is just boundary information. The real question is regulatory. And this is something that needs to be in each country, because basically you need to make sure you comply with the local laws about processing of medical information, which is highly sensitive. That's a tricky one, and I'm not sure it's an easy one to address. Information related to health and safety is something that can be done easily, but real medical information is a tricky one. An example right now, we have a trial in the US with a company monitoring blood oxygen levels. This one is okay. It's not very sensitive information. But sending sensitive medical files, it's highly regulated in most in the world, and I would not recommend getting into that because you have a lot of privacy issues here. And I'm still looking. I'm not sure we have other questions, at least not that I can see. No, that's it. I had a question about the IC tracking and medical information patient. I don't know if you see more questions.
So if you have any questions, please ask, or you can just type. So we will wait for like 1 or 2 minutes if the questions are coming up. This is Shankar. Like I have a personal question for you. Like being a faculty and like mentoring for students, actually you told that in present scenario in India, like we can work on emulator as such. So can you share a brief light on like how the students can work on it, partnering with the education program system you have, and what are the basics that the students need so that they can start working on Sigfox OG?
Yes. And yeah, I had a question from Vinod asking if the emulator is the same as the SDR dongle. Exactly. We are speaking about the same thing, Vinod. So this is a USB dongle. So if students want to start working with Sigfox right now, you need, let's say, 3 things. The first thing, obvious one, is internet connection, because you will need it at some point. But the real 2 things that you need is hardware. So it could be Arduino board, evaluation kit from silicon vendors such as Micro, which is how you will build something that extract information. And the second one is this emulator called the SD dongle. Basically, it's a USB dongle that can be placed online. You just plug in on the laptop, install the software, and you have a local extension of the Sigfox cloud. And in the near future, operations will officially start in India. You will be able to purchase what we call the access station, which are micro base stations that are more powerful than an emulator, and that are connected to the real network. Right now, I would say getting an Arduino, basically an Arduino board or whatever programming board you need, and this USB dongle. And I will send you the information over email, Shankar, about how it can be purchased. I can put you in touch with the supplier if needed. They are not built or distributed by Sigfox ourselves. They are distributed by partners.
Thank you, Mr. Nicholas. So if you could give the details, we will pass on to students as well, so they can work on that. It was a very wonderful session, actually. Like one more question, like, so you told that in India that we can start working on the emulator and you can purchase a dongle. So what do you think when it will come, the hardware architecture structure of networks of Sigfox will be implemented in India?
Plan is to make it happen. What I can do, Shankar, is I will today I will an introduction of an email with the people from Sigfox in India that can give you more details.
Okay, sure. Thank you. Thank you so much. So, dear participants, if you have any further queries, please shoot your questions in your Q&A. So we will be ready to answer. We'll wait for 1 or 2 minutes. Thank you. Dear Nicholas, we are getting a lot of comments of thank you from the participants. So I think we can wind up the session, and with your PPT and as well your data that you're following that you'll put through me, we will pass on to all the participants so that they can be in touch with you and with the Sigfox representatives in India as well, so that we can work with the education platform where the students as well as the innovators can work with the Sigfox OG technology. Anyway, thank you all. Thank you, sir. Especially now, I hand over the mic to Krishna for thank. Okay, thank you.
Okay, thanks a lot.
Thank you, sir. Thank you so much for the session.
Thank you all the participants, especially our speaker of the day, Mr. Nicholas. As well as I thank Sridev Sham, who was being the ECC of IEEE Kerala section, for hosting and being online for the session for the entire day for technicalities. And I also thank Anandu Dey, who is a student representative of IEEE Communication Society of Kerala chapter. And I also thank our beloved chair, Dr. Goman sir, for being with us, the panelist, for the continuous motivation. So I thank each and everyone, and on behalf of IEEE Communication Society Kerala chapter, I thank each and every one of you, those who attended. Stay safe and be healthy. Let's fight this COVID with all the webinars that we have. So thank you all. Thank you, dear Nicholas.
Thank you for inviting me, and have a great day to all attendees. Bye-bye.